Chapter 5, page 11, part 2. On the top of the page, we saw that we could figure out the enantiomeric excess and the amount of rotation a sample could have if I knew the percentages of each compound in the sample. But actually what happens more often is that you do a reaction and then you want to figure out how much of each compound or the percentages that you have. And this is an example of that type of problem. So let's say I take a look at this molecule right here. And I want to make that compound. So I do a reaction. And I know that this particular compound might rotate light minus 2.4 degrees or levorotatory 2.4 degrees. So I do a reaction. And I find that it doesn't rotate light minus 2.4 degrees, it rotates it plus 1.92 degrees. So that I make all of this compound, all of its enantiomer, or do I have a 50-50 mix or something in between? Well, let's go ahead and figure out how to work out this problem. So here we go. First thing I'm going to do is I can see in the problem that I need to find the amounts of R and S compound. So one of the first things I'm going to do for this compound is figure out whether I have the R or the S compound. So here we go. I'm going to say that the bromine is my highest priority group, the ethyl group is my second, the methyl group is my third, and the hydrogen is coming out at me. That's my number 4 priority group. So if I go from 1 to 2 to 3, that looks clockwise, but since the hydrogen's coming out at me, it really should be counterclockwise, or this is the S compound. So in this particular case, the S compound rotates light levorotatory by 2.4 degrees or minus 2.4 degrees. Now, if I made just this pure compound in my reaction, what I would observe is minus 2.4 degrees, but that's not what I'm observing. The specific rotation of my mixture is plus 1.92. What that means is that I didn't make mostly the S compound. The R compound would be dextrorotatory 2.4 degrees or plus 2.4 degrees. So in other words, if my net rotation is not negative and it's positive, I made more of the other isomer. So in this reaction, whatever I did, I made more of the other isomer that I wasn't looking for. But let's figure out the exact amounts. So how do we do that? Well, we're going to have to do a little bit of math here. So what percentage is 1.92 divided by 2.4? That's what we've got to find out, because that will tell us our enantiomeric excess. So if you take out a calculator and figure that out, you'll say 1.92 divided by 2.4 is equal to 0.8, or 80% of my sample is excess, is still rotating light. And since it's rotating light in the plus direction, then that means that it's going to be the R compound that I have more of. So my enantiomeric excess is 80% of the R compound. Now, what is the other 20%? Well, the other 20% is an even mix of S and R that canceled out. So that must mean that it's 10% S and 10% R that canceled out, leaving me 80% that didn't cancel out. So the total amount of the R compound is going to be the 80% that's in excess plus the 10% that canceled out, or 90% of my mixture is the R, and 10% of my mixture is the S compound. That would give me, once 10% of the S canceled out with 90% or 10% of the R compound, that would leave me 80% of the R in excess and 20% of an even mix of R and S that canceled out. That's normally how these problems are done. You normally know the specific rotation of at least one of your isomers. That gives you the specific rotation of the other one is going to be equal but opposite direction. And then as long as you know what the mixture rotates up here, you can figure out the percentages of the different compounds in your mixture.